Hello students, today we are starting one of the most important topics in calculus, limit and continuity. Suppose we have a function f of x. Now, tell me, what do you think it means when we say the limit of f of x as x approaches certain number a dot? This concept forms the foundation for understanding the behavior of functions. Let's begin with the basic idea.
Sir, is it the value that the function tries to reach as x gets closer to a dot?
Absolutely right. The limit of a function f of x as x approaches a is the value that f of x tends to as x gets closer and closer to a from both sides. Now, listen carefully to the formal definition. We say that the limit of fx as x approaches a is equal to L if for every epsilon greater than 0, there exists delta greater than 0 such that the modulus of x minus a is less than delta implies the modulus of fx minus L is less than epsilon. Mathematically, we write limit as x approaches of fx is equal to L if for every epsilon greater than 0, there exists delta greater than 0 such that modulus of x minus a is less than delta implies modulus of fx minus L is less than epsilon. Let's go through the main techniques to evaluate limits. The first method is direct substitution. If the function is continuous at the given point, we can simply substitute the value of x directly into the expression. Example, limit as x approaches 3 of x squared plus 2x minus 1 is equal to 3 squared plus 2 into 3 minus 1 is equal to 9 plus 6 minus 1, which is equal to 14.
Sir, what if we get an indeterminate form like 0 by 0?
Good question. In such cases, we use another method, the factorization method. In the factorization method, we factorize the numerator and denominator to cancel common terms. For example, limit as x approaches to of x squared minus 4 divided by x minus 2 is equal to x minus 2 into x plus 2 divided by x minus 2 is equal to x plus 2, so the answer is 4. Suppose we have the limit as x approaches 0 of the square root of 1 plus x minus 1 divided by x. Multiply numerator and denominator by the conjugate, square root of 1 plus x plus 1. Some very important standard limits are limit as x approaches 0 of sin x divided by x is equal to 1, limit as x approaches 0 of 1 minus cos x divided by x squared is equal to 1 by 2. Limit as x approaches infinity of 1 plus 1 by x raised to the power x is equal to e.
Sir, when do we say a function is continuous?
A very important question. A function f of x is continuous at x equal to a if three conditions are satisfied. First, fa is defined. Second, limit as x approaches a of fx exists. Third, limit as x approaches of fx is equal to fa. If any one of these is missing, the function is not continuous at that point. Types of discontinuity. There are three main types. 1. Removable discontinuity. Limit exists but is not equal to the function value. 2. Jump discontinuity. Left-hand limit and right-hand limit are not equal. 3. Infinite discontinuity. The function goes to infinity or negative infinity. Properties of continuous functions. Some important properties are sum, difference, product and quotient, provided the denominator is not 0, of continuous functions is also continuous. Polynomial, exponential, logarithmic, trigonometric, and modulus functions are continuous in their domains. Let's try a few examples. Example 1. Limit as x approaches 0 of tan x minus sin x divided by x cubed. Using series expansion, tan x is approximately x plus x cubed by 3. Sin x is approximately x minus x cubed by 6. Subtracting gives x cubed by 2. so the limit is 1 by 2. Example 2. Check continuity of fx equal to x squared minus 4 divided by x minus 2. When x is not equal to 2 and f of 2 is equal to 5. Limit at x equal to 2 is 4. But f of 2 is 5. So the function is not continuous. Example 3. Find value of k so that fx equal to kx plus 1 for x less than 1 and x squared for x greater than or equal to 1 is continuous at x equal to 1. Left hand limit is k into 1 plus 1. Right hand limit is 1 squared equal to 1. Solving gives k equal to 0. Practice exercises. Try solving these at home. 1. Limit as x approaches 1 of x cubed minus 1 divided by x minus 1. 2. Limit as x approaches 0 of sine of 3x divided by 2x. 3. Find value of k for continuity. F of x equal to kx plus 2 for x less than 2 and x squared minus 1 for x greater than or equal to 2. 4. Check continuity of modulus of x at x equal to 0. 5. Limit as x approaches 0 of 1 minus cosine x divided by x squared. Important formulas. Remember these key formulas. Limit as x approaches 0 of sine x divided by x is equal to 1. Limit as x approaches 0 of 1 minus cos x divided by x squared is equal to 1 by 2. Limit as x approaches infinity of 1 plus 1 by x raised to x is equal to e. Limit as x approaches 0 of e to the power x minus 1 divided by x is equal to 1. Limit as x approaches 0 of a to the power x minus 1 divided by x is equal to log of a. That's all for today's session. In the next class, we'll practice more problems and deepen our understanding. Keep practicing. Jai Hind.